Right. So we are almost 6:30 right now. So I think we'll be going live in a few seconds. All right. So good evening, all of you. Welcome to session number 4 of Vedic Max Part 3. So a very good evening to all of you. Welcome to Practically Live. So please confirm whether you are able to view the video and also hear the audio properly so that we are all set for the class. All right. Uh, so let's go to the chat box to see if anybody is there. All right. So it will take some time for the students to settle down. So let's wait for the students to come in. So welcome to the class. So if somebody is on the chat box, please confirm whether you can see the video properly and also whether the voice is coming properly. All right, I think students are just logging in, probably because it's a weekend. All right, so I just repeat, if there are some students in the chat, kindly give some feedback whether you are able to see the video properly or hear it. All right, so we are in session number 4. So although we missed the first session due to some technical problems, I'll just call it session 4 to keep the numbering correct. So let me use, so this is session number 4. Oh, all right. Okay, so anyway, we'll give 2 more minutes till somebody joins in. So in the meantime, I'll just explain what we are going to do in this class. So till the last class, we were discussing about multiplication. So we talked about vertically and crosswise, which is one of the well-known sutras or formula in Vedic mathematics. And we built on top of this vertically and crosswise. And then we further talked about what are the rules of doing multiplication. We called it golden rules of multiplication. And we saw that how we can apply vertically and crosswise in situations where there are more than 2 digits, that we consider 3-digit multiplication, and also we considered additional problems where we did moving multipliers. All right. Hi Charan, namaste, welcome to the class. So to just emphasize on this, let me just see if I can open. All right, okay, I'll not go to that today. So I hope all of you are filling the checklist for the course. So it's a very useful tool. So this is just a reminder so that if you have not started filling the checklist, kindly view the previous videos and try to see what topics we have covered and fill the checklist. And whenever you feel some topic is not clear, kindly ask that in the chat box. All right, okay, Charan is saying the voice is a little bit low. So let me just go and increase the volume. So I get, okay. So is it better, Charan? Is it better? Is the volume better? Hello, I hope everyone can hear me properly. Is the voice still low? All right, okay. All right, okay. So I'll try to talk a little bit louder now. So probably that was the reason why it was low. So what I was saying is, please view the checklist. So that was available in the chat box in the first lecture. So kindly download it and try to fill the checklist on a daily basis so that you understand which topics you have covered and which are the topics that you need to revise or you need to ask any doubt. All right. So we have almost finished with 5 minutes. So I'll just start with the class. Um, so others also who are viewing it, it would be good if you can give some feedback in the chat box so that we have a lively discussion and it is interactive. So the topic for today is called a special division, and what we are going to see is how to master the method of vertically and crosswise and do division problems with it. So before we begin, we'll revise till the middle of this class about the various sutras that we have considered up till this point, and I will also be introducing some of the newer sutras. So here is a sutra tree. So I'm going to arrange the sutras that we have learned and some new sutras. So we have learned almost 3 sutras in this class. So I'll just tell the English names. The first sutra was called by one more than the one before. Okay, Ekadikena Purvena, that was the Sanskrit name for that. So by one more than the one before, that is the name of the first sutra. And we have seen applications of that in terms of the 10-point circle and also the 9-point circle. The second sutra is called as all from 9 and the last from 10. It's very nice to remember this, all from 9s and last from 10. So this is an easy method for doing subtraction, especially when you want to do with base corresponding to multiples of 10. So we will come to a review of all these sutras once we begin with the class officially. So you have to just wait a bit. We'll see examples of these sutras. The third sutra we were familiar with in the last class also. It is called as vertically and crosswise. The other name for this is Urdhva Tiryak. Urdhva Tiryak. That is what is called as vertically and crosswise. The next sutra, we have not considered any examples till now, that is called as transpose and apply. It's called transpose and apply. Now we'll be also seeing a few more sutras. So I'll just call out the names just for familiarizing with the names. So if the samuchaya is the same, it is 0. So samuchaya is another name for what we call as ratio. So some of the students might be learning ratio and proportion. So samuchaya is another name for ratio. Now if one is in ratio, the other is 0. That is the next sutra or the sixth sutra. So I am giving the sutras in their order. So there is a number associated with each sutra. So I am just giving you the order in which it is written. So this is number 7, by addition and by subtraction. So by addition and by subtraction, that is the name of the sutra. So this is the 8th one, by the completion or non-completion. So almost 7 or 8 are almost of the same meaning, but depending on the context, you will apply either 7 or 8. So we will come to the examples maybe in a future class. For today, I will just discuss examples for sutra number 1, sutra number 2 and sutra number 3. Alright, so I think many of you have joined in the chat. So thank you for coming. Hi Prakash, hi Krishnamurti. Oh sorry, Kaushik. Hi, Gaddam. I think I'm pronouncing your name correctly. Hi, Prakash. Hi, Aditya. Once again. Hi, Charan. All right. So, Prakash is saying Nikhilam method. Yeah, Nikhilam method is the second one, the sutra number 2. So, just before we proceed, I just want to let you know how these are pronounced. So I'm not sure whether you will be able to hear the computer audio or not. So I'll play the first one. Oh, unfortunately, I don't see the play button coming in. All right. Let me try this one. Okay, so I'll do the pronunciation myself. Um, all right. So the first sutra is pronounced as Ekadigena Purvena. So you can pronounce after me also. So I won't hear it, but you can do for yourself. So Ekadigena Purvena. So this is the first sutra. In English, it is called as by one more than the one before. Okay. So I repeat, Ekadigena Purvena. That is the first sutra. The second sutra, as I think Prakash was pointing out, it is the Nikhilam method. So the actual name for the sutra is called Nikhilam Navatascharamam Dashataha. Nikhilam Navatascharamam Dashataha. So you can repeat after me. Nikhilam Navatascharamam Dashataha. So in English it is called as all from 9 and the last from 10. All from 9 and the last from 10. Now the third one is what we learned just yesterday and the classes before. It is called Urdhva Tirbyam. Urdhva Tirbyam. So you can repeat. So you can break the sutra into two parts. This is called Urdhva. Urdhva means vertical. Urdhva Tirbyam. That is crosswise, vertically and crosswise. That is the sutra. So we'll just look into the pronunciation of these three. So this pronunciation is just to familiarize with the sutra. And I had this audio where there was a little bit of singing voice. So you can always sing the sutra. So as I said in the first class, the sutras are written in literature in a very poetic manner. So if you remember these poetic jingles, then it would be easier for you to remember. So for example, I'll just try to sing the first. By one more than the one before. So try to make a song out of these sutras. So at least the English ones are easier. By one more than the one before. So try to make a song out of it. The second sutra, all from 9 and the last from 10. All from 9 and the last from 10. The third one, maybe you can sing in your own way, vertically and crosswise. You can maybe repeat it more than once and make it a jingle of your choice so that you recall it when it is required. All right. All right. So when I see the chat box, I think some of you have asked for doubts. Kindly note down your doubt. You can note down the doubt in your notebook. I'll give you some time for you to ask. We'll reach a refreshment point. At that particular time, you can ask the doubt once again in the chat box. All right. So let's go to the next slide. Okay. Oh, I think there was some problem. All right. I think now the sutras appear to come. Are you able to hear? If you are able to hear the sound, kindly give a thumbs up in the chat box. Are you able to hear the sutra being? No, I don't get any feedback. So I think my chat is running a little bit slow. All right. So let me just do one thing. Let me directly go. Okay. So some of you are giving thumbs up. So that means not everyone is able to hear it. So let me just go to the settings and check whether the desktop audio is on or not. Okay. So probably now you should start hearing. Okay. Let me just do this. Are you able to hear the voice?
Ekatikena purvena.
If yes, write yes in the chat box. If you were able to hear.
Ekatikena
Are you able to
purvena.
hear, students? Okay, right. So Manvita says yes. So this is how it is pronounced. Let's see this one.
By one more than the one before.
Good. All right. So let's go to the second sutra. So this is how it is pronounced.
Nikhilam navatascharamam dashataha.
I'll just do once again because the Sanskrit names are a little bit
Nikhilam
difficult to catch
navatascharamam
up.
dashataha.
Let's go to the English version.
All from 9 and the last from 10.
So that was all from 9s and last from 10. Let's play the third one.
Urdhva tirgbhyam.
So that is a Sanskrit name, Urdhva Tirgbhyam. Once again, I'll play that.
Urdhva tirgbhyam.
All right. So let's go to the English one.
Vertically and crosswise.
All right. So I hope everybody could hear that. So if time permits, I'll just show it once again at the end.
Ekatikena nikhilam navatascharamam dashataha and samuchchayate.
Okay. All right. So we are going to see some examples of Sutra 1. So Sutra 1 is also called as Ekadigena Purvena, or by one more than the one before. So the example is the squaring of digits ending in 5. So these are examples that are from multiplication. Okay, so we are only looking multiplication examples. So the first example is for Sutra number 1, by one more than the one before. I want to find what is 65 squared. So which is the easiest method to do it? So whenever a number is ending in 5 and you are going to square that number, then the ending two digits are going to be 25. Always. So always when you see a number squared and if the last digit is 5, then the answer will have the last two digits as 25. Now to find the remaining digits, what you have to do is take the other number. In this case it is 6. You multiply 6 with 6 plus 1. What is 6 plus 1? 7. So you multiply 6 with 7. The answer is 42. So the answer to 65 square is going to be 4225. Okay, the answer to 65 square is just 4225. Now I am going to ask you one more question. So can you find what is 45 squared? Similar method you can use. I'll give you exactly 15 seconds because it's easy to do. So what is 45 squared? That is a question. All right, almost 5 seconds are over. All right, so Prakash has given an answer. I'll just wait for one more answer to come in so that we can confirm whether others are also participating. All right, so Manvita and Arman has also given the same answer. So let's verify whether that's a correct answer or not. So 45 squared, 5 is the ending digit. So you will have 25 as the last two digits. Okay, 25 is the last two digits. Now to find the remaining digit, you just take the number 4, which I'll box here. So 4 multiplied by 4 plus 1. What is 4 plus 1? It is 5. 4 multiplied by 4 plus 1, which is 5. So what is 4 multiplied by 5? The answer is 20. So the final answer is going to be 2025. So just to check your curiosity, I'm going to ask you once more. What is 95 squared? This time try to give the answer within 15 seconds if you can, because the answer is going to be very easy. Alright, so 5 seconds are over. Still counting. 10. I think Prakash has the fastest finger here, it seems. Yeah. Yeah, Nirati and Manvita has also given the answer. So the answer is 9025. How did I get it? It is ending in 5, so the last two digits are 25. Then what I need to do is take the digit 9 and multiply with 9 plus 1. So 9 plus 1 is 10. That's why I could do it very easily. So 9 into 10 is 90. Alright, so that is the first example. Now I'm going to give you a slightly different example. So I'll erase all this stuff. And let's pick up the second example problem. You have to do 47 multiplied by 43. So you can listen now. After that, I will give you another example for you to solve. So consider the number 47 and 43. If you just consider the units place digit, it is 7 and 3. The units place digits are 7 and 3. And 7 and 3, they add to give the number 10. 7 plus 3 is equal to 10. Alright. So in this case, what you can do is you multiply the numbers 7 multiplied by 3. What is 7 multiplied by 3? The answer is 21. You put the answer like that. And since the tens place digits are the same, what you can do is 4 multiplied by 4 plus 1. Apply the sutra by 1 more than 1 before. 4 multiplied by 4 plus 1 is 5. So what is 4 multiplied by 5? It is 20. So the answer to 47 multiplied by 43 is going to be 2021. So I hope everybody understood. So this can only be applied when the digits in the units place are adding up to 10. So in the first example also the digit was 5. So you could have written 65 squared as 65 into 65. So these digits are adding up to 10. That is the reason why we could do it. So similar way, we are generalizing the first example, and this also works when the digits are not 5, but when the digits add up to 10. So I'll take another example. What is 54 multiplied by 56? So you can also try this one. So this is a problem for you. This is an exercise for you to solve. I'll give you maybe 30 seconds this time because you need little time to digest. So take your own time. Your time begins now. Okay, 15 seconds are over. I can see answers coming. Prakash, Manvita, Arman, Nirati. Yeah, good. So it seems everybody has agreed on the answer. Let's wait for 5 more seconds before we discuss. Alright, so let's look whether the answers given in the chat box are right or not. So I'll just change colors. We have to do 54 multiplied by 56. So what are the units place digit? It is 4 and 6. You multiply them. 4 multiplied by 6 is 24. And the tens place digit is just 5. So you just have to do 5 multiplied by 5 plus 1. What is 5 multiplied by 5 plus 1? 5 multiplied by 6. So which is what? 30, right? 5 multiplied by 6 is 30. So the answer is 3024. So congratulations to all the students who have written the correct answers. So don't worry if you have made mistakes also. So mistakes are part of learning. So once or twice you may get stumped, but you should always try to get up and practice more. Okay, so that is the whole idea of all these fun exercises. All right. So let's go to Sutra 2. So some of the students have already learned the name of the sutra. So this is called as the Nikhilam method, or all from 9s and the last from 10. So let us see a few examples of this. We have already dealt with in part 1 and part 2 of the course. This is just a revision. So I want to do multiplication of two numbers which are close to 100. So 79 is one number and 97 is another number. Both of them are close to 100. So 79 is 100 minus 21. So 79 is 100 minus 21. So I'll just write minus 21 in the side. Now 97 is 100 minus 3. So 100 minus 3. Alright. So whenever you get numbers close to 100, you can use this method. This is called as multiplication of numbers near a base number. So the base number that we consider here is 100. Now we are going to consider the multiplication of numbers closer to the base. So I have to do, what is 21 multiplied by 3? What is 21 multiplied by 3? It is 63. 20 multiplied by 3 is 60 and 1 multiplied by 3 is 3. So the answer is 63. Now this is the last two digits of the final answer. These are the last two digits of the final answer. To find the first two digits, what you have to do is cross addition. You take the number minus 3 and add to 79. So you have to do 79 minus 3. What is the answer? The answer is 76. Or you can do 97 minus 21. What we are doing is crosswise addition. Take the number which is on the opposite side and add to it. So the opposite number is minus 21, add to 97. What do you get? You get the number as 76 again. So both these answers have to be the same. In this method, either you can do this or this. So I have chosen this because this is easier to do. 79 minus 3. The answer is 76. So the final answer is going to be 7663. 7663 is the answer. Alright. Hope everyone understood it. So let's do one more exercise. So I'll just erase some stuff written here so that you can see the question clearly. So I want to do 107 multiplied by 98. So this is somewhat tricky. It's different from the first one. That's why I have put it here. So if you consider the base to be 100 as before, what you get is 100 plus 7 is 107. So you write the answer plus 7 here. And 98 is 100 minus 2. So you write minus 2 here. Now the last two digits of the answer is obtained by multiplying these two numbers, plus 7 and minus 2. Remember, there is a plus and there is a minus. So the answer is going to be minus 14. 7 multiplied by 2 is 14, but there is a negative sign here, right? So you have to consider that negative sign. So whenever there is negative sign, you can put a bar on top of it, bar on top of the number. Okay, whenever there is a negative sign, the actual answer is minus 14, but in the Vedic method we use this bar notation to write negative numbers. So minus 14 is written as 1 bar 4 bar. Clear? Now the next step or step 2 is cross addition. You can either do 107 minus 2 or 98 plus 7. Both are right. Both give the answer as 105. So the answer is 105 1 bar 4 bar. Now you have to convert this number into an ordinary number without any bar notation. So for that, what you can do is 105, you put two zeros. Wherever there is a bar, you put zeros and then write minus 14. Alright, so this is the same as the bar notation above. So the final answer is going to be 10486. So the final answer is 10486. Alright, so some students might have confusion here. So remember that this number 14, it has a bar on top of it. So that is why I am converting that bar number into an ordinary number. So I have to put a negative sign and I have to replace wherever the digits where bar is present, I put zeros there. So the final answer is 10486. Alright. Now the third question I am going to give you as a homework. So try this at home. So try this question at home. So I want to multiply the 3-digit number 996 with the number 79. It's a 2-digit number. So just to begin the calculation, I'll just give you some hints. Right. So 996 is closer to the base 1000. Alright. So in this case, you should choose the base equal to 1000, not 100, but 1000. 1000 is the base. Excuse me. So 996 is 1000 minus 4. So you write the number minus 4 on the side. So don't confuse with this. This is part of another problem. Okay. So 79. Now 79 is closer to 100, but now you have to write it with respect to base of 1000. What is 79? It is 100 minus 21. But if you add another 900, it would come to the base 1000. So this is going to be minus 921. Minus 921. Now you just do the usual method. Whatever method we followed here, you can repeat it and try to find the answer. So this is a homework for you. If you don't get the answer, you can ask the doubt in the next class. I'm happy to help you in the next class. Okay. So it seems Prakash has given an answer. So I'm not verifying the answer right now. So all of you can try. If you don't get the answer by the next class, kindly inform me. I'll try to explain it in class. All right. So we are going to proceed to sutra number 3. So this is a sutra we have already learned. It's vertically and crosswise. Urdhva Tirbyam. Okay. So I'm just slowly introducing the Sanskrit names so that the idea is concrete in the mind. So these Sanskrit names have got a lot of importance in some situations. If it is difficult, don't worry. Don't try to learn the Sanskrit name. English names are sufficient for us to do the problems. But those who have interest, they can learn up these names. All right. So sutra number 3 is the formula for general multiplication. We have already seen this. So I'm going to give this as an exercise for you. I'll give you exactly 15 seconds. Your time starts now. Solve 21 multiplied by 32 using vertically and crosswise. All right, let me see who has the fastest finger or fastest mental calculation here. All right, so Prakash, who comes next? Manvita, right? Charan. Okay, so these are the three students who comes in the list. So let's verify whether the answers they have given is right. So I'll just do mental arithmetic here. I'll not write the steps. So the formula for two-digit multiplication is VCV, vertical, crisscross, vertical. So you just have to remember VCV. So vertical step gives the answer as 6, crosswise step is 4 plus 3 or 7. The vertical step in the end is 1 multiplied by 2 or 2. So the answer is 672. I didn't use any in between steps. I did only a mental arithmetic here. So this is how the sutras are going to help you make calculations much faster. So try to learn up this important sutra. Vertically and crosswise is a very important sutra. Alright, I'm going to the next example. It's already solved for you. I'll just revise. So yesterday we talked about algebraic expressions. So algebraic expressions are expressions where you have this alphabet x in it. So whenever you have this alphabet x, you have to consider vertically and crosswise as we have discussed before. So 2x is there, 3x is there, 3 and 5 are there. So you do vertical step, 2x multiplied by 3x, the answer is 6x, 6x squared. So x multiplied by x is x squared. The next is crosswise or crisscross, however you want to pronounce it, it is fine. 2x multiplied by 5, which is 10x, 3x multiplied by 3, which is 9. So the sum is going to be 19. Finally, you have 3 multiplied by 5 or 15. Alright, so Prakash reminds us of the name. It is called as binomial multiplication. This is also called as binomial multiplication. So very good, you students are listening in the class and are dedicated. So very nice to note that. Now our third problem is a 3-digit multiplication, 504 multiplied by 321. So as we said, 3-digit multiplication is slightly different and the magic formula for that is VC, VC, CV. So first step is vertical, 5 multiplied by 3, which is 15, colon, C. C is crosswise or crisscross, 2 digits, 5 multiplied by 2 plus 0 multiplied by 3. So 5 multiplied by 2 is 10. So the third step is both vertical and crosswise. So I'll just write this step here. So this is the crosswise step. So crosswise step is 5 multiplied by 1, which is 5 plus 5 plus 4 multiplied by 3, which is 12. And there is a vertical step here. So VC in bracket meaning you have to do both vertical and crosswise. So we have done the crosswise, 5 multiplied by 1, which is 5, plus 4 multiplied by 3, which is 12. Now plus you have to do the vertical step, 0 multiplied by 2, which is 0. Put a colon after each step. Now we are in step number 4, which is crosswise, 0 multiplied by 1, 0, plus 4 multiplied by 2, which is 8, colon, the last multiplication is vertical, step 5, 4 multiplied by 1, which is 4. So the answer is going to be, so I'll write the answer here. So now you have to consider where there are carries. So whenever there are 2 digits, you have to consider carries. Alright, okay. So we start from the last place, which is 4. It's only a single digit, you write as it is. Next digit is 8. Now this number you have to add it. So add it, 5 plus 12 is 17. That's a 2-digit number. So whenever 2 digits are there, you have to consider carry. This 17, 1 will go as carry to the next number. So you write 7, 1 goes as carry to 10, 10 becomes 11. Now 11, you write the last units digit 1 and the 10th digit goes as carry to 15. So the answer is 16. So this is the final answer for this. How much is this? So this is 161784. That is the answer. So I can see two correct answers in the chat box. So once again, hope everybody understood the vertically and crosswise. So I'll just pause here to take some doubts. So if you have some doubts, we will pause here. Those who don't have doubts, you can read this question which is flashed on the screen. It's a question that is taken from the book called Leelavati, which I was mentioning yesterday. So you can just read the question. Others who have doubts, kindly put a thumbs down in the chat box so that I can understand that you have not understood something and I can go and explain that. Somebody who has any doubt in today's class or any of the previous classes, kindly give a thumbs down in the chat box so that I can go and explain that once again. All right. So I'll just give you maybe 1 or 2 minutes to do that. So in the meantime, other students who don't have any doubt, you can read this particular question. It's a very interesting way in which you can ask question. So all interested students can just look into the book called Leelavati. It's a very old book written in the 16th century or so by an eminent Indian mathematician Bhaskaracharya, and he is telling his daughter Leelavati. He is teaching mathematics to his daughter Leelavati, and this is the way in which he is asking questions. Okay, so I see a doubt being asked in the chat box. Manvita is asking, what is binomial? Binomial. So what do we mean by binomial? All right. So I'll just come back to this particular slide. So let us clear Manvita's doubt. So by binomial, what I mean is any expression. So we have already understood that this is an algebraic expression. A binomial expression is one that has two terms. So binomial, it has two parts. Bi meaning, the meaning of bi is two, and binomial. So this second part you can understand it as two terms. So for example, this expression 2x plus 3 multiplied by 3x plus 5. There are two parts. This is part 1, this is part 2. That is the reason why it is called binomial. Now if I only consider the first part, so consider 2x plus 3. So this is what is called as monomial. So mono meaning mono meaning 1, and we said the remaining part is approximately translated as one term. So this is just one term. So product of two monomials will give you a binomial. All right. Is it clear, Manvita? Is it clear? If it's clear, kindly give a thumbs up. So in short, just binomial means there are two terms. That's what it means. All right. So I imagine that Manvita has understood it. I am going to the question here. So I'll read the question. Fawn-eyed little Leelavati, tell me how much is the number 135 multiplied by 12? If you understand multiplication by separate parts and by separate digits. So this is the first question. So let's try to solve the first question being asked to Leelavati. So what is being asked? You have to find what is 135 multiplied by 12. What is the easiest way to do it? 135 multiplied by 12. What is the easiest way? You split the number 12 and write it as 10 plus 2. I am splitting the number 12 and writing it as 10 plus 2. So I can use what is called as the distributive law. Many students might already know what it is. So this can be written as 135 multiplied by 10 plus 135 multiplied by 2. So this is what is meant by separate parts. So in the question there is separate parts and separate digits. So we are going to separate the multiplication like this. So what is 135 multiplied by 10? It's 1350 plus I have to do 135 into 2. 135 into 2 is just doubling, right? So you can apply the sutra what is called as anurupyena. So the distributive property in Vedic mathematics is called as anurupyena or proportionally. So 135 is 100 plus 35. The double of 35 we know is 70 and the double of 100 we know it is 200. So the final answer is going to be 270. Double of 135 is 270. Now you add this up. How do we add? 1350 plus 270. So 1300 plus 200 is 1500. 1500 plus 50 plus 70. So that is 1620. The other way to do it is 270 is 300 minus 30. So you first add 300 to the number 1350. You get 1650. Then subtract 30. So 1650 minus 30 is also going to give the answer as 1620. All right. Okay. Yeah, it seems Bhuvan has got the answer. Bhulakshmi has got a doubt, it seems. So Bhulakshmi, could you just tell which part you have not understood? Is it this question or is it previous question? Is it this question or any previous question? All right, I don't see any response. So hope the question was clear to you. The question is to find the product of 135 and 12. So the method that we used is to split the number 12 as 10 plus 2. Then we used what is called as the distributive property. In Vedic mathematics it is called as a proportionally property. So you do 135 into 10 plus 135 into 2. So 135 into 10 is 1350, 135 into 2 is 270. And I said that you can consider 270 to be 300 minus 30. So you add 300 first, then you subtract 30. So that was that problem. All right. So hope all of you enjoyed this particular problem solving. There is one more part in the problem. So I'll just quickly tell about it. So the question continues, how much is the product divided by the same multiplier? So that is a very direct question. So if you are given the answer 1620, you want to find what is 1620 divided by 12. So is there a easy method to find this or not? That is the question. So we will find out an easy method. So that is what we are going to learn in the next few slides. All right. So now we are going to jump into the division. So only once you have mastered multiplication, you can do division problems easily. So whenever you get time, try to practice more problems related to vertically and crosswise, because the methods that we are going to learn in division are exactly borrowed from vertically and crosswise. So that's the reason I am saying focus on this single sutra, which is vertically and crosswise. That is going to benefit you maximum for doing both multiplication as well as division. So today we are going to do very simple rules for division, which is called as base division. So we have already considered the term base in vertically and crosswise when we studied. So base is any number which is multiple of 10. So the meaning of the word base is multiple of 10. So for convenience you can learn this definition. So in the beginning we are going to consider the simplest base, which is the number 10 itself. So I want to divide 2-digit numbers by the number 9. So I am just considering the simplest division case. I want to divide a 2-digit number. Somebody, can you just tell me a 2-digit number in the chat box? Bhulakshmi, can you just suggest a 2-digit number, any 2-digit number? All right, I'm asking. So Bhulakshmi had a doubt. That's a reason why I'm asking Bhulakshmi. Can you just give a 2-digit number? Bhuvan, I will take your number next. Okay. So I think Bhulakshmi is not attending the class. All right. So in that case, I'll take Bhuvan's number 69. So I want to do 69 divided by 9. Okay. So this is an example. So when I want to do 69 divided by 9, in conventional, whatever you have learned in school, you will write something like this, right? 9, and you will put a bar on top of this, and you will do the multiplication table of 9. So you know 9 times 1 is 1, 9, 9 times 1 is 9, 9 times 2 is 18, 9 times 3, etc. If you know the multiplication table, you know 9 times 8 is what? 72. So 72 is greater than 69. So you just need to reduce 1. 9 times 7. So that is the closest number which is less than 69. So I'll write 7 on top. 7 is the quotient and the product is 63. Now you will get the remainder. So let me just name this for you. This is what is called as the remainder. I'll put a R here, and this number 7 is what is called as the quotient. So this is the quotient, this is the remainder. Now imagine that if this is a very large number and you don't know what is the multiplication table of 9, then it is not possible to do this division. But the Vedic mathematic method does not require you to know the multiplication table of 9 or any other number. So it's very direct. You just have to identify that 9 is close to the base 10 and can be written as 9 minus 1. Alright. Only thing that you need to understand here is 9 can be written as 10 minus 1. Then what you do is you draw the, so I'm going to do the Vedic mathematic way. So I'll use a different color. So the same thing you can draw here, 69 and 9, and below this number 9 you put the 1. So 1 is coming from this. So 9 plus 1 is 10. That's why you put the number 1 here. Now what you do is here you directly copy the number. You directly copy the number below. It is going to be 6. Directly copy. Then what you do is you multiply 6 with 1. What is 6 with 1? The answer is 6. You add that to the number 9. So 6 plus 9, what is that? It is 15. Now since there are 2 digits, you have to reserve 1 digit for the remainder. So the answer is 6 is the quotient, remainder is 50. So for the time being, you keep this answer in mind. I will come to further simplification. Now in this problem, the conventional method we understood that the quotient is 7, remainder is 6. So the answer that we got here is 7 or 6. So this is the way in which we are going to write the answer. 7 is the quotient, remainder is 6. In the second method that we learned, which is written in red here, we got the answer as 6, remainder as 15. Later I will show that it is possible to write the answer like this. So you have to wait for 2 more slides for that. So before we proceed, let us do some simple problems. Okay, so this is just an example warm-up problem. So I will erase this now and I will show you an easy example. I'm going to do 23 divided by 9. So the steps are like this. This is how you should write. 9 you write here, 23 inside you write. You bring the first digit as it is without any change. The first digit is the tens place digit, which is 2. So you bring it as it is. Next, what should you do? You should add this digit to the next figure. That is, you add 2 to 3. 2 plus 3 is 5. Now that is going to be the remainder. So this is 2 digits. So one digit you should always reserve for putting the remainder. Okay, so I can see many students, it seems, are using calculator or something, or maybe you are doing the division using decimal places. Okay, so that is why the answers are different. So Bhuvan, I think you are doing decimal division. So at least we will not do the decimal division unless it is required. So decimal division meaning you will get the answer as for example, in the chat box Bhuvan has written 7.666 etc. So that is the representation in the decimal number system. So what we are doing here is not the decimal system but quotient remainder system. So that is what I introduced in the beginning. What we are doing here is quotient remainder representation. Both are right. So Bhuvan, your answer is also right. But at least for understanding purpose, we are choosing the quotient remainder representation. All right. So I'll just do one more example before we end today's class so that this method is solid for all of you. So once again, I have to divide 51 divided by 9. So the method is I just have to copy the first digit, the tens place digit 5 as it is. Then add the 5 to the next units digit, which is 1. I'll get the remainder as 5 plus 1, which is 6. So 5 is the quotient, remainder is 6. Is it clear to everyone? If it is clear, we'll see some practice questions. So are the practice questions visible now? Okay, I think it is visible just now. So let's do this one, 71 divided by 9. Okay. So how am I going to write it? 71 is inside, 9 is outside. I'll just put a dash here. You bring the 7 as it is, no change. You add the 7 to the next place. 7 plus 1 is 8. That is the remainder. So this is the answer. Quotient is 7, remainder is 8. So you can see how simple you can do without knowing the multiplication table of 9 and doing it. You just have to do addition here. It is as simple as addition. You bring the first digit as it is, then you do addition of that received number to the next. What about here? 46. So 46 is slightly different, but anyway, I'll try to write it. So let's change the numbers here. So 46 is what? Right, let's go back. Okay, so 46 divided by 9. The first step is to bring the tens place digit 4, which is as it is, down. Now the next step is to add 4 to 6. 4 plus 6 is 10. So this is the answer that I got. 4 is the quotient, remainder is 10. Alright. Now, if you look carefully, the remainder is 10 here, which is a number greater than the quotient. So whenever you see the remainder to be greater than the quotient, you can do one more simplification. What is that simplification that you can do? So in 10, there is a 9. What is 10? 10 is 9 plus 1. So I can get a 9 from this number 10. So what I will do is do 10 minus 9. The remainder becomes 1. Since I have subtracted 9, I can add 1 to the number 4. So this is recalling that sutra by 1 more than 1 before. 4 plus 1 is 5. So this is the simplified answer, 5 and remainder 1. So Manvita, you have to increase the quotient by 1 because I am getting a 9 out of the remainder 10. So that is why you have to add 1 to the quotient. So I will talk more about it in the next class about this remainder modification method. I will be talking more about it in the next class. Now I think we have finished with time, but before we end, does anybody have got a quick answer to what is 60 divided by 9? Any method is fine, the conventional method or the method that we just learned now. Anybody has got the answer before we close? I'll give you 1 minute to answer it. We have almost finished with time. What is 60 divided by 9? It's quite direct. Yeah, Manvita writes it's 6.66. Anybody knows what is the, so quotient is 6. So from Manvita's answer, I understand the quotient is 6. What is the remainder? Yes, it's very easy to do this, right? So you just bring the first digit as it is, so 6. Now add the first digit to the second digit, that will be your remainder. So remainder is 6. So the answer that we write here is 6R6. So 6.66 is also right. 6R6 means 6 is the quotient, remainder is 6. Some students may get confused. So what I will do is, just to make or remove that confusion, I will write the full form of a remainder. So this is the for all. So remainder 6. Quotient is 6. Quotient is also 6. So the quotient for the problem is also 6. The remainder is also 6. So hope everyone understood this particular problem. So with that introduction to base division, I will end today's class here. So hope you enjoyed the session. So do practice. So before I leave, I will show you one exercise for you. So today you are going to get the second worksheet for this course. So I have given last week also one worksheet, but in that unfortunately it was a source file. So many of you had not known what to do with it. This time the worksheet, it is appearing in the chat box. So you can just click in that Google form and you will be redirected to this. There are two questions in this, exercise 1 and exercise 2. You can answer the worksheet within the Google form itself. You need not download any PDF file, etc. You can directly answer it here and you can get the feedback right away. Alright, so do attempt worksheet number 2 and we will discuss about it in the next class. So for all the students, this worksheet is also available in the description box of the video. So in the current video, you will have the description box that also has the same worksheet. Alright, so I will wish you all the best for the week, and let us all meet in on next Friday. So till then, goodbye and namaste.